Welcome students. Now we are going to start the topic refraction for class 12 physics. Chapter name ray optics for the Cbse, NEET as well as for the IIT. So mainly here we are focusing on the boards actually, and for that we are just taking few points for more elaborating, which is helpful for the NEET and JEE purpose. Let's begin with the first topic, which is a refraction actually. Students, when a ray of light incident obliquely, this is a particular angle which is a less than 90 degree. So obliquely on a surface separating to transparent medium. So the best angle for obliquely in the case is between 30 to 60. Okay, this is the mean actually, but the exact angle you can take, like theta will be, you can take less than 90 degree, and the perfection you get between the 30 to 60 degree. Okay, so when a ray of a light incident on a this particular angle range, the surface separating two transparent medium, its direction changes. Students, if the direction is changes, that means somewhere the velocity is also changes. Now, during like moving from a one media to another medium, frequency remains constant. If the frequency constant, so we know that from here, like C is equals to lambda pi t or C is equals to nu lambda. If frequency is a constant, so speed either change or wavelength either change. So direction changes, that means velocity changes, it means wavelength also changes. Clear? This phenomena is called actually refraction, as you can see here. Initially the wavelength is a lambda 1 and you can see the range, and now the wavelength is a, as you can see from the here also, wavelength little bit changes. So optically rare medium, if the light rays, like if the light rays are incident on a one medium which is a rare and emerged from the denser medium, so it will bend towards the normal. In this, we have some law of also refraction which we studied in the class 10th. Now we are just revising the things. The ratio of a sine of an angle of incidence to the sine of angle of refraction is a constant, is called as refractive index of the second medium with respect to first medium. So it is given by sine I by sine r is equals to n2 by n1, which is equals to n2 1 is equals to 1 n2. Okay, where n1 is equals to refractive index of first medium and n2 is the refractive index of the second medium. Or n2 n1 sine I is equals to n2 sine r, but n2 is equals to c by v and n is equals to c1 by v1 or c by v1. What is the n over there? So this is the absolute refractive index. C velocity of a light in vacuum and v velocity of a light in medium. So n2 by n1 comes like frequency remains same, so L1 by L2. Velocity of a light in the medium v is equals to f by lambda. So from here we can say the refractive index for the second medium to the first medium is lambda 1 by lambda 2 and v1 by v2. And n21 is equals to 1 by n12. It is called optical reversibility also. Few points which you have to note it down. The refraction frequency f does not changes, but velocity and wavelength changes. If n2 is less than n1, then r is less than I, and refracted ray bends towards the normal, as you can see. When the light ray is incident, on the point of incident, the light must go in a straight path, but they will actually bend towards the normal. Second point, If n2 is greater than n1, so r is greater than I. In this case, refracted angle bend away from the normal. So if this is a light of incident ray and the light going from denser medium to rare medium, it will bend away from the normal. Now moving on the application part, when refraction of a light takes place through a rectangular glass slab, the emergent ray is a parallel to the incident ray and there is a no deviation, but the ray suffers lateral displacement or shift with respect to incident ray. Glass. So light rays incident from a rare medium to the denser medium. It will bend towards the normal. And glass is a denser medium. So denser medium to again light rays wants to go in the air. That means rare medium. So it will bend away from the normal. In this case, as you can see, incident ray, if we go like rays more. So for that case, both the rays are parallel to each other. This is a called lateral shift. Little bit shift over there. This is a called lateral shift. So this is a complete diagram when the light rays incident on rare medium to the denser medium, light rays bends towards the normal, and if the light rays passes from a denser medium to rare medium, it will bends away from the normal. This is a lateral shift which we are saying as a delta x. This is the incident angle or angle of incidence. This is the angle of refraction. From alternate interior angle, as you can see, this angle is equals to this. So this is the angle of a refraction. It's a glass slab. It's thickness of a glass slab. Its emergent angle. Again, this is the incident ray, refracted ray, emergent ray, and this is a lateral shift. I hope you understand each and every part. This is a normal by which we can detect how much angle of incidence and refracted changes. So from here, delta A and B, you can do pause and note it down each and every point also. So delta A and B is equals to delta A, M and B, this angle. Clear? Is actually cos R is equals to AM by AB. So AB is equals to AM, which is a T, cos R by cos R. So AM is equals to T, distance traveled by the light inside the glass. How much distance actually glass, like light travel in the glass, we can calculate AB is equals to T by cos R. From triangle ABC, sin I minus R is equals to BC by AB. Sin I minus R. This is the angle of I minus R. This, we have to take now this angle. So from here, BC, which is delta x, is equals to AB sin I minus R. Delta x is equals to T by cos R sin I minus R. From here, we can assume we can find the value of lateral shift also, like how much shifting of the light rays actually have. The bottom of the tank filled with water appears to be raised when viewed along the normal direction. This is also an application of this. Like the coin is actually here, but its images will look like here. So this is also a form of a apparent depth and real depth concept, which is based on a refraction. Refractive index of water with respect to air is N21 is equals to real depth by apparent depth, which is equals to N21 by N2 by N1 T by T1. N is equals to T by T1. N1 is equals to rare medium, N2 is equals to N of a denser medium. From figure, shift delta T is a real depth minus apparent depth. So T minus T dash, you just put this value and get the value of like shift. So shift, this will be delta T is equals to 1 minus 1 by N times T. Students, I'm just want to elaborate this diagram to you. Like there will be a few things which we can do. Like this is a source. This is a what? Source. And from source light is actually emerge, like actually going outside. So this is an incident ray. This is a denser medium. So light rays always away from the normal. Because of this, if we back the light rays from here and here similarly, so its apparent image will be formed here. This is not actual is, this is an apparent image. So sometimes we can do this experiment like if we just throw a coin or we just like stand a pencil. So pencil is also a little bit like bent looking, but actually this is a not bent. This is a cause of a refraction. Understood, student? So it's a like apparent image will be formed upside. Because of that, we see this kind of a thing. So this is a T is the thickness of a water or a real depth. Few point which we have to note, like this is a rare medium, this is a denser medium of a water, and in this there will be a fish. So if a bird wants to attack on this fish, so actually the light bends. Okay, and if that like bird is actually put, the bird is actually located at a t distance. So like if the fish will see, so fish will assume okay bird is where at the delta t like t plus delta t height upside. It's actually fish is thinking like okay the actual place of this bird is upside, but the bird is actually little bit down. So for that scenario, bird can easily catch because this is a actually humor we can say that, or we can say centrifugal things are or apparent thing are observed by the fish. So if the observer is in the denser medium and the object is in the rare medium, then the apparent depth is a more than real depth. Refractive index of water with respect to air is n21 is a given by. So what will be happen actually student in this case, like we taken a particular fish. So fish क्या सोचेगी कि जो हमारा bird है वो actually बहुत ऊपर है, but वो बहुत ऊपर ना होकर के they are at a particular distance, a finite distance are there. Because of that, if fish wants to like open the mouth and wants to come upside, अगर वो ऊपर आना चाहेगी बिकॉज वो ये सोचेगी कि जो हमारा बर्ड है वो कहाँ है काफी ऊपर है. सो बिकॉज ऑफ दैट they may catch by this bird or eagle. Okay, so this is a formula which we received earlier. Here we again put this formula, okay, and we get the value of a shifting over there. So this shift will be get if we see the object from the denser medium and earlier it was the rare medium to denser medium. Similarly, the apparent position of the sun we are looking here because of refraction from the earth. So this is the horizon, this is the atmosphere. Due to the refraction, sunlight through the atmosphere is visible little bit 2 minutes before. Okay, and like we are saying this problem is early sunrise and delay sunset, and like 2 minutes after actually sunset. So before the actual sunrise we can see like the sun also, and after the sunrise again 2 minutes we can see the sunset. And apparent flating, overall shape of the sunset and sunrise due to the cause of refraction. We are saying as a atmospheric refraction also. Atmospheric refraction. So later on, we just look this point like what is atmospheric refraction. I hope you heard like study in the class 10th also about atmospheric refraction. Now we just move on to some MCQ questions so that more clearance will be comes. Mathematical form of Snell's law is n2 sine I is equals to n1 sine r. n1 sine r is equals to n2 sine I. n1 sine I is greater than n2 sine r, or n1 sine I is equals to n2 sine r. This is the correct answer for this question. Students, for more elaboration, I hope you remember that sine I by sine r is equals to n. And n is a what? n2 by n1. So from here we can write like this: n1 sine I is equals to n2 sine r. Second question, when light travels from one medium into another medium, then which of the following quantity remains same? Wavelength, frequency, velocity, refractive index. Students, the correct answer for this question is the frequency, as I told you earlier. So this is all for today's class, students. I hope you understand the term refraction and their main points. In the next class, we will see the total internal reflection. Till that, take care everyone.